Well, thank you very much for hosting me. It's quite a thrill to be able to speak to a group like you. I normally speak to big power conglomerates or industrials, and they're on the other side of the fence of this conversation. So I'm glad to be speaking to one of the largest community renewable generators of the world. And I don't know if you guys appreciate it, but as a Canadian, very proud of what you guys have done. You guys have done a lot more than you think you have. Now, from my side, thank you very much for hosting me in your native land. Interpretive dance. I listen to the instructions. Today, I'm going to be talking to you about a bit of the future. I call it a data nexus between energy and data. In my background, I've been working since '98 in energy systems, but I'm a computer scientist with software engineering background, and I have some postgraduate work at MIT in deep learning. So I know a little bit about AI and a little bit of energy systems. I do applied research, and one of the things that I also wanted to mention is we do have an AI Asia Pacific Institute, which is a non-for-profit that we founded about 6-7 years ago when we got really scared about what TikTok was doing. And we try to find a way to speak about things that we worried about on the ethical development of learning algorithms that we couldn't speak about in our home corporations. So in that said, I try to bring to you an idea of what would happen, I guess the invisible thread of what data infrastructure will be, and the fact that there is a significant amount of change coming our way, and you are perhaps one of the countries that is best positioned to manage this in a much better way than we have. Let's begin with this. I was asked as an intelligence unit of the Aboitiz conglomerate. So you have some context there. Aboitiz conglomerate, we have land, construction, logistics, Coca-Cola, banking, about 45% to 50% of the generation of the Philippines in power, renewables, hydrocarbons, of course, trading, retail, and energy selling, as well as commodity buying. We're the largest coal buyer of the Philippines. And on top of that, it's all owned by one family. So it's the kind of company that would be illegal in our countries. But the advantage there is it's a beautiful data set. As a data science researcher, I get to see a lot of what the country goes through with it. And they asked me, what will be the power demanded by data centers in 25 years? There's no one in the world today that can answer that question, just so you know. Whoever's answering that question is because they're making some assumptions, and we all know that our assumptions are at least going to be wrong, but how wrong are they going to be, right? And in doing that, I went back to how could we answer this? Imagine that I had to answer this 20 years ago, 25 years ago. So when I graduated school in '98, someone asked me, what's going to be the power demand in 2025? And I would have not mentioned data centers. In fact, I would have said, what is a data center? Right. So in that sense, I went to perhaps some of the best forecasters there is in the power industry as a country, which is Singapore. This is also where I reside. They do have publicly published numbers of everything they forecasted since 1998. And what you realize with Singapore is even though they got their population growth within a 1% average difference between what they forecasted and what they actually got, what they did not get right is almost close to 15% energy demand. Now, from an OECD perspective country, they're the ones that got it the best. All of us, Australia, Canada, we all got it wrong by way worse than 20% on energy demand. And in fact, I think that's why groups like you exist. Because the disruption of energy was a lot larger than we could predict. And what we saw with that is that there's unbearable certain things that we didn't get right. But what makes really important for the forecast that we're doing is why we got it wrong. And it is the fundamental structural changes. As it was mentioned before, we think data is a fundamental structural change. AI coming to our economies is not just another technology. And what I realized too is that the role of the home, that's what Singapore got wrong. The smart meter and the role of electricity at the home. And you know what was wrong in the Australian forecast from 2000 to today? Just how disruptive the homes were going to become. Disruptive from their side, in my side, when I see customers balancing the power of energy decisions in this country. So if we take that and extrapolate into data, there's a lot of lessons learned. The lessons learned come from this. Data centers are not just going to be storage and availability, maybe even processing of data. That's where they are today. That's what they're contracted to be, 100% reliable, really high latency, et cetera. They're becoming more and more what we call inference engines. And an inference engine is the ability to turn data into intelligence. Before we legislated that our data needs to be here, but data is not that useful if you don't learn from it. When you use ChatGPT, what you're doing is you're basically creating learnings from language approach from your data, or from the data that you feed it, or from the data that's out there. So data centers are going to become data to inference centers. Today in Australia, I think the amount of contracts on passive compute are around 70%, maybe more, I'm not too sure. But it is going to transition more and more into inference. And when it transitions to inference, it actually explodes to a degree. I'll give you an example. GPT-3 bill, electricity bill on the first level of GPT-3, which was trained somewhere in 2020, was $16,000. GPT-5 bill is $62 million, electricity bill. So training algorithms and the path that we're going, by the way, is very energy intensive. So we've even gotten to the point where energy equals intelligence. You cannot obtain intelligence without energy. And that would also mean that if we look at our population today, there's only about 3% of the population that have interacted with AI. So even though it feels like you and your neighbor and your friends all are using AI and ChatGPT, you're a very small subset of the population. In the world, there's less than 3%, and then less than 0.3% that pay for AI, they'll have a paid license, and less than 0.004% the ones that actually build agents or something with it. So if you consider this in power terms, right? Let's say that we're in 1940s, and only 3% of the population have access to electricity. What was the curve of adoption of electricity that changed the way our economy works? One of the biggest predictors of poverty is lack of electricity. We're in a moment like that again. Once this becomes 20% of our population, the entire explosion of intelligence will drive the energy industry. So that was an important thing that we had to do to understand that data centers today are not what data centers are going to become tomorrow. And forecasting of energy today cannot be done without forecasting data use, compute, inferences. So, if you look at objectively, energy spent on data centers, if I had 1 terawatt of energy, and I wanted to get the most money out of that 1 terawatt of energy, which industry should I invest it into? Reality is that the data centers are probably the best bang for your buck, for your megawatt. So they're an economic engine. And there's a lot of things that they can do to bring efficiency into our own energy grids. There is a multiplier there. Now, they are disruptors for sure, and the disruption is happening because also the way that they're contracted as almost data smelters, if you may, 24/7. But that contract can also bring some benefits. It's a lot of displaced inefficient demand, even though we only see this visible load. Now, for us to be able to do that forecast that I was asked to do, then I had to understand how we're going to use intelligence in the future. That is the best way for us to truly forecast how much power we're going to need. And if inference matters, then I had to create a measure of inference per household or inference per person. So we went to what is the AI structure in the future? What would happen in your home? And we connected with Montreal Institute of Learning Algorithms, which we co-research in ADI with. And we basically have a foresight exercise done with them, which describes that our use of AI, I can go back, would be 4 stages. Now, the stage that you're seeing today is the stage of you interacting with AI directly. Asking one question, getting one question back. You do maybe 10 calls a day, maybe 15. The more advanced users, 30, probably. And you are orchestrating on a very efficient level what you need. However, once we move to, wrong button. Once we move to level 2, which is this line is mutually agreed to be about 2025. That's why you heard so much about agentic AI last year. Now you have assistance. The interaction with the AI is no longer you directly, but is you through an agent. You're going to start having a lot more goal-oriented, and the number of inferences grows. An example is I have about 5 agents that help me right now for work only. I'm at about 100 inferences per day because I have an agent that checks the stock market for me, another one that checks ticket prices for flights, another one that tells me about my schedule and try to coordinate my travel. And eventually, we will all have that in our homes. Now, let me give you a picture of what your homes would look like. You will have your bathroom become your lab, your medical lab. And every morning, as you relieve yourself in the morning, there'll be a little test done to see how you're doing with health. And hopefully, there'll be a closed loop to your medicine. We call that dynamic treatment regimes. And that will keep you always pre-diabetic, pre-heart, hypertense, pre, but never actually developing, precancerous, etc. Then your closet will be a tiny little marketplace where you could actually make money by the styles that you choose. And although a lot of us men don't really think that's a big deal, trust me, it's a big deal. Now, I know if you were born in the 70s, like me, you think we can opt out from this. I don't need this at all. I grew up with rotary phones. Your children won't be able to. For your children to go home, to go to work, to get a bank loan, to study, they're going to need to have a layer between reality and them. Even a physical layer where they have the smart gadgets to help them interact with the world. So this new reality in your home, where you're going to have the ability to have a full studio to learn, to have monetize in your closet, to be able to have your refrigerator do your shopping for your food, would be a non-optional for the next generations. That would be the new reality. And in there, we're moving from 75 households, inference per household, to probably a few hundred per person, maybe even a few thousand per household. And the line between small business and residential homes will start to blur. Your everyday activity as a human will have an economic element to it. So the good thing is we'll bring in the empowerment of economic value to the home through intelligence. The downside is this world right here, the reasoning world, which is the one that we're going to. It's a world where there's a lot more power demanded. Now, let me go back to this one. We created this sample of 1 million homes. This is a Southeast Asian paradigm, but it's valid still for the representation. How many terawatts do we need to sustain 1 million homes? And the agreed number in Southeast Asia is about 1 million gigawatts. Sorry, 1,000 gigawatts, so that's 1 terawatt. How much would it grow if we digitalize the economy to the level that the researchers are saying we're going into? And this is where it becomes really interesting. Today, you're very familiar with large language models. The blue line, right? It's a very inefficient way to learn. And I'll give you an example. Imagine you were looking at the Last Supper of Jesus painting. If I had to train an algorithm on this, and I use large language model approach, an attention architecture approach, I have to describe it with words. How long would that take? Jesus is here, he's looking this way, the shade is looking, facing him face this way, the expression is this way. You have a paper of 30, 50 pages to try to teach that picture through using large language model. But there are other techniques. If you just look at the picture, it's a lot more efficient than the descriptions. When you go to a museum, you don't go first to the description. The first thing you look at is pictures. It's more intuitive. It's more efficient. That's called joint embeddings. The head of Meta, Jan LeCun, the AI research, was really big on joint embeddings to the point that he had to leave Facebook because they wasn't supposed to talk about it. Then, if I put lines between each of the apostles and Jesus and score each line on an influence weight between the edges, Judas is a -2, Peter is a +50 as it pertains to Jesus. That's graphical learning. So we're not going to revolutionize intelligence by pure large language models. And one of the fears that we have right now, one of the races that we have right now in the world happening, is that OpenAI and all these companies are betting of massive growths of compute based on pure large language models. Access. If you wonder why there was 40 gigawatts asked of power of Australia, even though they only needed 6 gigawatts for data centers, or phantom demand, as they call it, it's because of this. It's speculative. I don't want to comment whether there's an AI bubble or not, but some of those that understand AI suspect that this speculation drives a lot of volatility, not certainty. And it's shown in the industry that supports it. When we get to a world that is more mature, you're going to see all kinds of different architectures being played into your everyday, into your home. As a data officer of a power company, I want graphical learning for my grid because it's a network. I don't need it described with words. I want to optimize my network with a graphical learning data set. So that means we're going to diversify a lot how we use these inferences, and therefore the portfolio of data centers will become very diversified. We'll have to for them to be effective. So bringing data centers can help us do things like energy data system optimization. They can actually make us more effective in the way that we deliver power, improve our capacity with dynamic line rating. It can also help us predictive maintenance. We can unlock a lot of capacity by ensuring that AI is applied in our grids. So even though they are energy hogs, at least that's how we use them today, and how their customers use them today, because this is a lot based on the contracts they have with Google and so forth, they could also be a great opportunity. And now I give you an example of something that I see. If there was an incentive and a structural difference in the way we think data centers, they can become a leader to help us bring more renewable energy into the country. Bring your own power data centers located in reses can be a way for us to not go back in our sustainable commitments, but to try to move forward in our sustainable commitments. Now, I know that current business model of the data center rejects this because they want to be closer to you, but this is where the power of the people comes into play. Inferences that I just spoken to don't need to be done in a centralized place. They can actually be done on edge at your home. So you know the role you played in democratizing the access to power by being one of the biggest power generators of renewables, 26 gigawatts of installed capacity, right? You can play the same role with compute. You can bring your own compute in your home, create networks of community compute that does inferences on those homes, and balance the infrastructure of the data centers. Now, there's two futures in my view. There's the hell, where you have 12% of national demand created or improved or increased by 2050, and this could actually be more. Or you can, and a huge risk of wholesale prices. Or we can be proactive at planning and figure out a more sustainable way to deliver power and deliver intelligence to the average home in Australia. Sustainably. We don't get to go back in our commitments. Now, if you don't hear data centers talk about this right now, they're a very young business. They are a critical infrastructure business that doesn't understand they're a critical infrastructure yet. I mean, they understand it because it keeps our planes in the air, it keeps our hospitals running, but they don't behave like a critical infrastructure yet. How do I know that? The obligation I have in a utility is to give a 25-year outlook of energy, and how am I supposed to support that for an affordable price? A data center is to get built in 18 months, and they can pay back somewhere close between 3 to 5 years. Which power plant here gets paid back in 5 years? And you see, they haven't been incentivized to think like a critical infrastructure. So that's the one kinds of things we got to change. My advice would be, obviously, joint planning. You cannot plan energy anymore without data, and you cannot plan data without understanding energy. And one of the reasons I speak to so many conferences is I got a lot of data people that have no clue how the energy industry works, and I got a lot of energy industry people that don't understand at all what data technology looks like. So we have to start talking to each other. Second, we really do have to create an incentive for data centers to become a driver of green energy, not a bottleneck that would force us to go back to coal, which is what happened in the Philippines. We got to find synergies in industries. Energy industry is just one, but you could do a synergy with mining. You can do a synergy with airports. And then instead of contracting just the capacity that Facebook gives you from afar, you're now contracting capacity for the development of Australia, for the development of the home as well. And then finally, we need to find a way to increase flexible profiles, to diversify their compute portfolio. And a great way to do that is you guys, the home. I'll finish my talk with this. I worked for GE for a couple of years. I was their chief data officer for power services in Asia. The way that GE introduced appliances in the home was not for an appliance business. It was to stabilize our turbine business. If you ever had a GE refrigerator that didn't break for 30 years, that's what it was doing. It was helping us close the loop so we could sell more stable turbines and make the business case for our turbine business. Now, that was GE's decision. It was a very smart decision. But what if you develop your own appliances? What if the reason there is a need for compute in Australia was something driven by communities and not just by Facebook, Google, and Microsoft? If we were to create new startups, build our own agents, do concrete allocations of how we're going to use compute in Australia for Australians, our own appliances, then we can stabilize the data infrastructure business in Australia. And that's a great opportunity, by the way, because no one in the world is thinking of a sustainable, green data business yet. So Trump did you a favor. By delaying ESG, and it will come back, you could be the only responsible green compute choice in the world. And that has the smell of services and products, knowledge-based economy, not just resources. So we don't only sell compute to Australians, we sell transformative economy services. And in my view, the great aspect of it is this could be an agenda for future made in Australia. The democratization of the data business is as important as what you did with the democratization of the energy business. So you can take control. We can balance what's happening in our data infrastructure. I thank you for your time. I'll just leave you with one last thing, which is a question someone asked me. What am I worried about? The reason we opened the Institute is we see a huge asymmetry with the way the technology of AI is being developed and how it's being used. And one of the biggest problems is how do we balance that? How do we bring reason and responsibility to the way the data and the intelligence business is growing in the world? This could be one way. And Australia could be one of the leaders on showing us how to do that in the world. Thank you for your time.